Hi, it's time for another math easy solution. We're going to discuss further into the substitution rule for integrals and look at part 2 of the example series. But before I get to that, I just want to quickly recap on the substitution rule, which I proved in my earlier videos, so make sure to check the video links below. Basically, if u equals g of x, a differential function whose range is an interval I, this basically this is saying the range or whatever values this u can be, and f is continuous on I, because when we plug in u inside basically g of x here, this is just saying that like when you plug it in, f will exist and it's continuous on this in this domain, which is the range of u. Basically, then if you have a function, let's say like this, f of g of x times g prime of x dx, then you could simply substitute this u equals g of x and the differential of basically this du inside to replace g prime of x d of x, and so basically this whole function will equal to integral of f of u times du. So make sure to watch video link below on proof of this theorem right here, or this rule. So the examples I'm going to go over today are these ones right here. And I'll first go over example 1 here, which is this just the integral of x divided by square root 1 minus 4x squared, and always remember to put dx at the end there. So here, if I write down example 1 here, basically now to solve this integral, as you can see, it's pretty complex. So the idea of substitution is basically substitute, change a variable here to make it easier. So in this case, we'll substitute, as you can see here, we want to simplify the square root function by substituting u equals to basically 1 minus 4x squared. And then if we take the derivative or a differential here, we'll get basically du equals to the derivative of 1 is 0. So bring this 2 down, so negative 8x, and then always put 8 dx. Learn more about differentials in the video link below. So now we can, well, we're almost ready to plug this in, but first we got to solve for this x dx. We could replace this with, because we have it over here, so we could write x dx equal to, well, du, and then divide by this negative 8, so negative 8 right here. So now we can plug this into this formula. So we'll get basically integral of, well, there's going to be a negative 1 over 8. Yeah, negative 1 over 8 times it by, now this is going to be, well, just du, and then this is square root of u. So as you can see, we just plug this x dx, which is this part, and then this u inside here. So we have this function here, and then we could basically solve this derivative, I mean the antiderivative of this 1 over square root of u. Well, this is just a constant here, so just put that out of there, negative 1 over 8, and then the derivative to get to this is actually just going to be, well, 2 times it by square root of u. You can see more about antiderivatives in the video link below, and also plus c, because as you see, if you take derivative of this one right here, this is the power of 1 over 2, so you bring in the 1 over 2 down, and then minus the power of 1 on there, it will be negative 1 over 2, and you'll get that. So we have this part to get simplified further. This will just be 1 over 4 square root of u plus c, and this equals to basically, once we plug back this u inside, just 1 minus 4x squared, we get 1 over 4, and then times it by square root 1 minus 4x squared, and then obviously plus c right here. So now, like always, you could check this by taking the derivative, and also you could also graph it. First I'll take the derivative. So yeah, if we take the derivative of this function right here, we should basically get, this is a square root right here, so you bring down a 1 over 2, so we'll have equals to basically negative and then 1 over 2. This becomes, well, 1 over 8, because there's 2 times 4, and this is power of 1 over 2, so that we bring that down to square root 1 over 4x squared right here. Then using chain rule, we're going to get a negative times by negative 4, and then bring this 2 down, so we'll have a negative 8x right here. Yeah, so we have this part, and the c is 0, so then we'll just have this, and we can cancel this. There's a negative, it becomes positive, and the 8's cancel, and we're just left with equals right here of x over square root 1 minus 4x squared. So this is our original question. That's the answer. Yeah, so this is a good way to check the work that it's correct. But another way is you could even graph it. I'll graph it right now. Yeah, so here I've graphed the two functions with Google Graphing Calculator. Basically, this blue one right here, that's just this function right here, which we'll call this f of x right here. And then this is our integral. We'll call this g of x, and this is basically equals to the integral of f of x right here. And then as you can see, this is another good way of checking that it makes sense. Basically this is the red one right here, and it looks something like an oval shape right here. And then this is the f of x, which, because if g of x is the integral of f of x, this just means that it's the antiderivative, or that the derivative of f of x right here equals to g of x right here. Oops, actually I made a mistake there. It's the derivative of g of x is equal to f of x right here. Because if this is the integral, then to get f of x, you just take the derivative. And so basically, as you can see from here, if this is our g of x right here, then the derivative, as you can see, it's rising to infinity at this 0.5 number. As you can see, it's rising to infinity there. And then here, the derivative is 0 at this function, and that's where it's 0. Then it goes to, basically, in this case, there's a negative infinity. And there you go, there's a negative infinity here. So this is a good way to check that it makes sense, and it does. Put a check mark there. So now let's look at basically example 2, which is a bit simpler. Just take the integral of e to the power of 5x dx right there. Yeah, so if I write down example 2 right here, so now to substitute this, because, well, we know the antiderivative of e to the x, so we'll try to make it look like that by writing basically u equals to d of equals to 5x. Yeah, 5x right there. So if you take the derivatives, du is equal to, well, this just equals to 5, and then there's going to be a dx like always. So solve for dx right here. This just equals to du over 5. So now we could plug in everything, and we will get basically integral of, well, there's going to be a divided by 5 right here, and then there's going to be a e to the power of u. E to the power of u, and then there's going to be now the du there. So this is basically replacing it. And now the antiderivative of e to the u is just e to the u. So we'll get e to the u divided by 5 plus c. And there's our answer, and we can just plug back the 5x inside. So we'll get e to the 5x divided by 5 plus c, and there is our answer. And once again, you could check it by the graphing or taking the derivative. I'll just take the derivative quickly here of 5x. Yes, I'll take the derivative of this one. As you see, the derivative of e to the 5x is just equals to e to the 5x. And then you obviously have to multiply by 5 right here. And then, because there's to be divided by 5 using the chain rule. And then there's the c is 0, the derivative of a constant 0. These cancel is e to the 5x, and that's a quick example on that. That's a quick check. Also, I just want to make another point here. I said this was g of x, and this equals to integral here, and that equals to basically this function. But I forgot there's a c value, so in this case, I just assumed that c equals to 0. Doesn't matter what c is. Basically, if you had c is equal to, let's say, anything else like 10, all this does is this just makes it go up higher. But the derivative is still going to be infinity here. It's going to go to 0. So the derivative is not affected by the shift of up and down based on the values of c. Anyways, that's all for today. Hopefully you'll learn from this video and these examples. And like always, you can download these exact notes in the video description below. And thanks for watching. And stay tuned for another Math Easy solution.